In today's session, we are going to see how we will use decision tree classifier to solve a classification problem. Okay, so first import libraries. So let's import pandas library. Let's import NumPy, and also let's import from sklearn. Let's import pre-processing. Uh, so we know that pre-processing is used for we use pre-processing while you want to do encoding or else you want to do scaling. So we also import from sklearn dot model selection. Let's import train test. So since we are looking for working on decision tree classifier, let's import decision tree classifier algorithm as well. So from sklearn, import decision tree classifier. Okay. And also from sklearn.matrix, let's import confusion matrix as well. From sklearn.matrix, import confusion matrix. Also, we need accuracy score as well too. So for that, from sklearn.matrix, let's import accuracy score as well. Okay. So I guess this is done. Also, we can also plot the ROC curve, receiver operator characteristic, receiving operating characteristic, or any under the color also we can find out. So let's from sklearn matrix import ROC AUC, ROC curve, ROC curve, as well as area under curve, area under curve. Okay. And also we need visualization libraries as well. So for that, let's import matplotlib. From matplotlib.pyplot import. Sorry. Actually, this should be import matplotlib.pyplot as PLT. And we need seaborn library as well. So seaborn library usually used for drawing heat map. Okay. So I guess this is fine for now. So let's read CSV file. So, okay, what's the problem with this? Cannot implement decision tree classifier. Oh, this should be DCI. Okay, this should be from sklearn.tree. Okay, from sklearn.tree import decision tree classifier. So we have imported the basic packages that are required for solving our algorithms for building our model. So now let's read CSV file. So data frame is equal to pd dot read underscore CSV of let's pass the CSV file. Let's see the CSV file first. So we have a banking data set. So in the banking data set, we have age, job, marital, education, default. So these are the features, that is, these are the columns that are present, and the out the predictors are these variables. These variables are the predictors, and the dependent variable is the deposit one. Okay, so let's read this CSV file. So bank.csv is the file name. Okay, so let's print data frame. Okay, so these are the variables that are present. So like these are the independent variables, and we have to predict the dependent variable, which is deposit. I guess it should be deposit. Let me check it once. Okay, fine. So what we'll do now is that let's print the top 5 rows. Okay, for that, so let's print top 5 rows. We have a data frame dot head is the top 5 rows of our data set, data frame. So let's see if there are any null values that are present in our data frame. Okay, so for that we will do df dot is null dot sum. Okay, what happened? Okay, the df dot is null. Okay, fine. So you could see that there are no variables where null values are present. So now what we will do, we will draw a correlation matrix. So let's draw a correlation matrix. Okay. So for that, so let's see df dot for. Okay. So this is the correlation matrix that we got. Let's draw this in a heat map. Okay. So what we'll do, SNS dot heat map of data frame dot correlation. Okay, so let's include the values I naught is equal to true. So these are the variables that are present. So let's make sure that it's only up to 2 floating point values. So format is equal to 0.2 floating values. We need only the 2 floating values only. Okay, this is fine. So you could see that if there is any correlation between the independent variables, so we don't find any correlation that much between the independent variables. So what we'll do right now, let's move to the next part. So now let's check for outliers. Okay, let's check for outliers. So plt.figure. So let's increase the figure size. Let's pass it 10,6. Okay. So now let's see. So let's check outliers if there are any outliers that are present in balance. So if you see this, this is a categorical variable. This is also a category. This is also categorical. This is also categorical. Let's see if there are any outliers that are present in our balance column. Okay. So df dot balance dot plot lot dot of kind is equal to, let's plot box plot. Okay, this should be df dot. Okay, yeah, if you see this, so instead of drawing like this, what we can do is that SNS dot cat plot of x, y. Okay. So we just need box plot, right? XNS dot box plot of data frame. So what's the value x? So we have to pass data. Data is equal to data frame and via column is x is, let me see, balance. Okay, so this is not printing that correctly. So let me take y is equal to balance. Okay. This is not giving a accurate result. Instead, what we can do, so in our data frame, we can plot box plot. So let's take df dot box plot of which variable you want. So balance, right? So okay, we have got a balance over here. So there are so many outliers that are present in our data set. So you have to take care of this. Okay. So what you can do is that data frame dot describe data frame of balance dot describe. So describe function will give you the 5 point summary. Okay. So you could see the minimum is -6847. So deposit value is in negative. So balance is in negative balance over here. And minimum is -60847 and the maximum is 81,204. So what we'll do is that let's take care of the balance in such a way that so whatever value is less than 122, let's remove the drop the values, and whatever value greater than 1708, let's drop those values. Okay. So data frame dot drop of df of, so what we have to pass, df of balance is less than 122. So it will give true or false. You have to pass inside the data frame. This should be a square bracket. Df of balance less than 122. Drop, okay. So we have to drop those values. So let's pass as index, okay. So we want to drop, what we are getting here is that, so let me show you this by running this code. Let me take this. Okay, so Control C, Control V. Okay. So df of balance less than 120, what it will give? So it will give wherever balance is less than 122, that has been filtered out. Okay. Okay. So that is so it is giving values wherever balance is less than 122. So we have to drop these values only. Okay. So otherwise we can pass dot index. Okay. Let's see the index what it will give. So what we'll do is this gives index values. Okay, so we are dropping these index values, X and Control V. So we are dropping the index of these values where balance is less than 122. So and we want to, and this is on axis is equal to 0 on row. Okay, so actually it is in the row. You don't have to worry, but still I'm passing it just for your reference. And also we could place in place is equal to 2. So we keep in place is equal to 2 so that this whatever operation is happening, it happens to our original data frame. Okay. So your whatever values you're dropping, that the values will be dropped in your original data frame as well. So okay, so this is done. So also we have to perform operation where we have to drop values. We df dot drop of. So we have to drop values where balance is greater than 1708. 1708. Okay. So we have to drop that as well. And now let's see. Let's plot it. The plot df dot box plot of balance. Sorry. This should be small. Okay, you could see, right? So instead of plotting like this, so you can also plot like dot plot of kind is equal to, sorry. So you have to plot like df dot. So we want balance, right? Balance box plot. Df dot balance plot of kind is equal to box. So you could see clearly, right? So we have taken care of this the outliers now. So similarly, let's look at age as well, age column. So if there are any outliers that are present in our age column, df dot age dot plot of kind is equal to box plot. So yes, you could see that there are some outliers. So let's see df of age dot describe. Let's describe. So this will give the minimum value, that is the 5 point summary. It will give min max 25% of the value where it lies, 50% of the value where it lies, and 75% of the value where it lies. So what we can do is that you can see outliers over here, right? So what we can do is, so values which are greater than 48, let's filter that out, filter it out, okay? So let's filter out values which are greater than 48. So of df dot drop of data frame of age is greater than 48 dot index. So index values it will drop. So axis you don't have to pass, it's your wish. Let's try. Yeah, let's try and pass 0, even though it's by default axis is 0. If you want to check, you can check here as well. Axis is 0 by default, so you don't have to pass axis over here. Now we have to make places equal to true so that this operation happens in the original data frame as well. Now let's print df of df dot age dot plot of kind is equal to box plot. So yes, we have taken care of the outliers that are present in our age variable as well. What you can do is that since 25% of the values lies in 32 and minimum is 18, so you can also filter out, you can also drop the values that are less than 32 as well. So let me drop the values in our age column where value is less than 32, because 25% of the values lies in around 32, and for that we have made that. So now if you do the plotting, so we can see the change over here. Okay, so it's fine. I mean, you don't have to worry. We have taken care of outliers. So we had these many outliers. We have taken care of these outliers now. So now, what are the other variables that are present in our data set? We have day. Okay, this is numerical. This is categorical, numerical. So now let's plot it for day column as well. So df dot day dot plot of kind is equal to box plot. Okay, so we don't see any kind of outliers that are present in our day variable. So just ignore that. So we don't have to take care of this. So now let's see duration. Okay, if there are any outlier present in our duration, df dot duration. So till now we haven't reached to the model building part. You need to wait for that. First, we are doing the processing, pre-processing, data pre-processing. So it will take time. So before moving into model, we have to process the data so that it is good for building a model. Okay, df dot duration of dot of kind is equal to box. Let's see if there are outliers present. So there are so many outliers that are present. So let's see df of duration dot describe. Okay. So what we'll do, let's filter out some values. So so let's make it like values less than 132 and values greater than 507 minutes. Duration is in minutes. So duration is days, I guess. Yeah, duration is number of days. So let's filter out values. So let's copy this same code over here. So so we have to pass duration greater than. So greater than what you want to pass, duration greater than 507, so more than 507 days. So instead of 507, let's pass our own value. I will give it as 209, okay? If greater than 209, so drop those values, okay? And similarly, if duration is less than what to say 106, let me say 106, let me say 100, okay? So there is no also drop. So now let's see df dot describe. So df dot sorry duration df dot duration dot plot of kind is equal to box plot. So we have taken care of outliers. Okay. So till now we have been taking care of outliers. So similarly, we can take care of other variables, other columns as well, where outliers are present. We need to make sure that all the columns are in such a way that there are no outliers that are present. So once you reach that part, then you can go with the building of model. Before that, we have to do some data pre-processing. Let's do data pre-processing. So in our data set, you could see that there are more number of categorical variables. Okay, you could see that we have categorical variables over here like job, marital, education, default, housing loan, contact, month, housing loan, contact, month, and P outcome and deposit. Okay, so we have to do data pre-processing so that once you have complete your processing, the pre-processing of data, then you are able to build your model. So before that, you won't be able to build your model because you need the variables to be in numerical form. So you need to convert. So you have to perform label encoding. So once you do the label encoding, then you can go with the model creation. Okay. So now let's do the data pre-processing part. So I will continue in the next video, the data pre-processing and the model building. So thank you for attending the session.